Alright everybody, today we're going to talk about logarithm functions. These are day one notes. So first things first, a log is an exponent. It's a tool we use to be able to solve something like that. But first let's go ahead and let's look at some graphs and see what is happening here. We're going to graph it and we're going to talk about the domain and the range. So if I pop ln of x, natural log of x, into my calculator here, so I'm just going to click natural log x, and I graph it, this is what it looks like. So if you notice, it kind of goes through here. It looks like it disappears here, but it actually doesn't. There is a horizontal asymptote right there. And so it does go through 0, 1. So let's go ahead and graph that. This goes like this. It's going through here. And it goes downward like that. So that is what the natural log of x looks like. If we look at this and we look at the domain, remember that domain means what x can be. So if we look here, it starts at 0, but it doesn't actually reach it. And then it goes to infinity. The way we usually write domain, though, you could see it written as x is greater than 0. You can see it written that way, too. Range is what y can be. Well, it goes down forever, and it's slowly going up forever. So the range here is going to be all of the reals. Then we have logarithm of x. Now, natural log is just a fancy type of logarithm. It has a base of e, whereas a regular logarithm has a base of 10. So if we go into the calculator and we type in log of x and we graph it, this is what it looks like. So it looks very similar, but it's a lot more smashed down here, aka compressed, and there is a point right here at 1, 0 still, and everything else is the same. This still goes down, there's an asymptote there, everything else is kind of the same, but it's definitely more compressed than the others. So it's going to look like this. Unfortunately, you might be hearing my dog in the background, but hopefully you don't, because he's going crazy right now. So the domain is what x can be here again. Same thing, right? So you can either say it's 0 to infinity, or you can say x is greater than 0, however way you want to say it. For the range, it is going down forever and is going up slowly forever. So the range would still be all reals. The next thing we're going to look at is 1 over natural log x. And let me just take a moment right here to let you know that if I'm going too fast, which I probably am, you can pause the video and catch up. So please pause the video whenever you need to pause it so you can catch up. Do the right thing. So we have 1 over natural log of x we're going to put into the calculator. I'm going to hit clear. 1 divided by the natural log of x. There it is. Beautiful. We're going to graph it. And it is hard to see, but actually what does happen here is there's going to end up being an open dot right here. An open dot on 0. I mean, it looks like it could be an asymptote there, but I'm telling you that it is not. There's going to be an open dot on 0, and there's an asymptote here. Let's do this. Right at that. So we're going to have this graph going down. It comes up to here, and there's an open dot. And this graph here goes like this. Okay? And it's because you can't take the natural log of a negative. So notice that nothing's going over into the negative side of the x values. Let's look at the domain. This one's a little goofier, right? So I'm going to use interval notation. It starts at 0, but it doesn't include it. And it goes to 1, but it never actually reaches it. And then it never actually reaches 1, but then it goes right forever to infinity. So your domain would be that. It's 2 little pieces. And the range, you're looking up and down. Well, if you notice here, the one thing that y cannot be is 0. So it's all the reals, but y cannot be 0. And last but not least, let's look at the square root of the natural log of x. I'm going to go into my calculator, and I'm going to do square root natural log of x, and graph it. And there it is in all its glory. Now you may think this is an asymptote too, but I'm here to tell you, because that's what I get paid to do, that there's actually a point here, and it is a regular old darkened in dots, no open dot stuff going on. So it does look like this. The domain, if you look at this going left to right, it looks like it starts at 1 and goes to infinity. You may also write this as x is greater than or equal to 1. So either one of these would be totally fine. Looking at the range, the lowest y value is 0, and it goes up forever. So a couple of ways, like you could write y, I would use this. Y is greater than or equal to 0. Okay, so it's just some graphs, and now you know where to press your buttons on the calculator, all right? They do look cray-cray, I get it, but the main thing is, do you know where to look in the calculator? Do not type it in the calculator, and do you know how to figure out your domain and range by looking at? All right, so remember, you can pause this if I'm going too fast. Transformations happen the same way as we've always done them, and if all else fails, graph in a calculator and look to determine the domain and range, okay, which is what we just did. So let's go over here and let's actually talk about this. So in Algebra 2 trig, you've already talked about logarithmic form and exponential form. I call it the circle. You can call it the circle of life if you want to call it that. Whatever works for you. So it starts at 5, it goes to 25, and then it's going to the 2 if you look at this. So if you're undoing this, 5, 25, and 2. So 5 to the second is 25. 5 to the second is 25. 5 to the second is 25. See it? 5 to the second is 25. That's how you would write it right here. I don't know about all this circle. Like, not like this circle. Get that circle out of here. I don't like that. There you go. So I do this circle. 5 to the second is 25. And we'll do some of them together so you'll see it. Natural logarithm, I've already mentioned, has a base of e. E is a number, just like pi is a number, e is a number. So instead of saying log base e of x, math people came up with natural log x. Common logarithm has a base of 10, so log base 10 of x, we just straight up write as log x. If you see no base, it's a 10. Notice that right here. If you see no base, it's a 10. If you see no base on a natural log, it's an e. We got it written right there. So let's talk about this here. It says convert to logarithms. So what you're going to do is you're going to write log and you're going to write equals. And you're going to do the circle of life. So this to this gives you this. So go into the basement here on the bottom. Read this aloud. A to the b equals c, right? A to the b equals c. There it is. A to the b equals c. Let's do this next one here. This is an e, so you want to write natural log. You're going to start in the basement, write your equal sign. You're going to start in the basement. You're going to go over here, and then you're going to go over here. So e to the x equals 2. E, ooh, that's a terrible looking e. Here we go. E to the x equals 2. Let's discuss a little something right here. Remember back in the day when you had that handwriting paper? Do they still do this in school? I think they do. Let's talk about where everything is situated here right now. So you've got log base a of c equals b. Do you see where the a is? Make sure it stays down there. Do you see where the c is? It's on the same level as the log. I'll have people writing all kinds of crazy stuff. It'll look like this. I'm not even kidding. Nobody knows where this is at. It looks like it's in the air to me, so to me it would be wrong. So make sure that you are writing it correctly. So let's go over here. Convert to exponential. These are always easier because look, c to the y equals x. C to the y equals x. So it's all about that circle. Just do the circle. And you may be thinking, like, why in the world are we doing this? This is ridiculous. It's weird. It's because we're doing this because you got to know how to solve that. Look at it. It looks easy, right? Well, we got to get some skills so we can solve it. All right, so going on to the next page. Find the exact value without a calculator. You've got this. Well, we don't know what this equals, so guess what? It equals x. It equals an unknown, so it equals x. Then we're going to do that circle. So 10 to the x equals 100. 10 to the x equals 100. Now, it'd be real nice if you could get these sides to match. Well, if you break up 100, it's 10 times 10. So isn't this 10 squared? So if 10 to the x equals 10 squared, x must equal 2. And every year I got students that just box this as the answer. No. That's not the answer. I want to know what is x. So x is 2. Again, we don't know what this one is over here. Set it equal to x. Do the circle. 4 to the x equals 1/16. Alright, so we got to make these look the same. And I always tell people, if all else fails, break everything down to its tiny components. But you don't really have to. I mean, look at 16. That would be 4 times 4, right? So we've got 4 to the x equals 1/4 squared. Those match the 4s, but the 4 squared is on the bottom. You need it on the top. So remember exponent rules. If you take something and you move it to the other side of the fraction, it changes the sign on the exponent. So 4 to the x equals 4 to the -2. And now we got matching going on. So x must equal -2. That is your answer on that one. Over here on this, set this equal to x. This is e. E to the x equals e to the e. So therefore, if we match these up, x equals e. Remember, if I'm going too fast, Pause it. 5 to the x equals 25. I'm sorry, square root 5 to the x equals 25. Now this looks weird. We got to break up this 5 and make it, we got to break up the 25 first, make it 5 times 5. So this is 5 squared. But square root of 5, how do you write that as an exponent? Do you remember? It's 1/2. So now we know that 1/2 x equals 2. You multiply both sides by 2, and x equals 4. Alright? And I know I did those quick, but please pause it, write it, go back, rewatch it, etc. I just got to bust through this next problem, and I should be good. Find a so that the graph of f of x equals log base ax contains the point. So remember, what's a point tell you? It tells you x and it tells you y. And remember, we call y f of x. So when I go over here and substitute this in, we got 3 equals log base a of 27. And then you're probably like, what do I do? Well, you can't do nothing with it. But let's rewrite this in a form that we are used to seeing. So let's rewrite it like this. Now do the circle. A to the 3 equals 27. What can you do next? You're going to break up the 27. So that's 9 times 3, and that's 3 times 3. So that's 3 to the 3rd. So if a to the 3rd equals 3 to the 3rd, then a must equal 3. Now I know I did those pretty quick, so make sure you do go back and rewatch. And, you know, I would really just try to write it down maybe the first time and then go back and then rewrite and then rewatch the whole thing, just so you got it down. And until next time, goodbye.